Have you ever really stopped to think about what happens when you click on something? I mean, it feels completely instantaneous, doesn't it? But in that tiny fraction of a second, you're actually kicking off this invisible, high-speed journey that zips across the entire planet. So let's follow that click and see just how deep this rabbit hole really goes.
And that's really the heart of what we're digging into today. We're going to trace the life of just one single click, all the way from your screen to a server that could be thousands of miles away, and then all the way back. And in doing so, we'll uncover the incredible hidden machinery that makes our entire digital world possible.
You know, at its core, the goal is about as simple as it gets. Your computer, that's you, the user, wants a piece of information from another computer, the server. That's it. But to get from A to B, it has to make a journey through that massive network in between. And that's where all the magic and, frankly, all the complexity really happens.
So let's start. I want you to think of your click as the beginning of an epic story. Your request is the hero, and it's about to set off on a quest through the huge and, yes, sometimes dangerous world we call the internet.
But before our hero can even step out the front door, it's got to get ready. You can't just, toss a request out into the wild. It has to be broken down into pieces, packaged up, and addressed perfectly to have any hope of reaching its destination.
Okay, I know this might look a little intimidating, but don't worry. This is something called the OSI model, and the best way to think about it isn't as a complicated blueprint, but more like an assembly line that gets your click ready for its trip. It starts at the top with your application, gets presented in a universal format, opens a session, chooses its method of transport, finds its way through the network, creates a data link, and then finally it travels over the physical wires. We're just going to focus on a couple of the key layers here.
We start right here, at the very top. Layer 7, the application layer. This is the part you actually see and touch, your web browser, your email app, whatever it is. This is where your click is born. It's where you tell the computer what you want to do. It's the whole reason for the journey in the first place.
Next, your request heads down to the presentation layer. Think of this one as part diplomat, part security guard. It translates your request into a universal language that basically any computer can understand, and, this is crucial, it wraps it in encryption. But it's really important to remember this, that encryption is like an armored car. It protects the data while it's moving. It does absolutely nothing to check if the message inside is flawed or even malicious.
And now we get to a huge decision point at layer 4, the transport layer. Does our data need, say, a premium signed for delivery service? Or is a fast, just drop it and go courier better? TCP, that's the reliable one. It checks and double checks that every single piece of data arrives safe and sound. UDP, on the other hand, is all about raw speed, which is great for things like streaming video or online gaming, but it doesn't bother to double check. And that choice has massive implications for both performance and security.
All right, so our data packet is now prepped, it's packaged, and it has its delivery instructions. It is time to send this thing out into the world, and this is where we meet the internet's hardworking postal service.
Every single device hooked up to the internet, everything from your phone to some massive server farm, has an IP address. It is the single most important piece of information for our packet's journey. Without it, the packet would just be lost. It's the digital version of a full street address, making sure the packet knows exactly where in the world it's supposed to go.
And this right here highlights a really critical security idea. We're kind of conditioned to think of an IP address as an identity, but it's not. It's just a location. It tells you nothing about whether the sender is a friend or a foe, which is a mistake a lot of people and even some security systems make. Just trusting an IP address is a really shaky foundation for security.
So who's reading these IP addresses? Routers. You've got one in your house, and there are millions of them that make up the backbone of the internet. Every single router is like a postal worker at a giant sorting facility. It takes one look at the destination IP address on our packet and makes a split-second call on the best path to send it on next.
Now, it's super easy to get routers and firewalls confused, but their jobs are fundamentally different. A router's main goal in life is connectivity. It just wants to get your packet to its destination as fast as possible. A firewall's job? That's policy enforcement. It's the security checkpoint, asking, hey, are you on the list? Are you actually allowed to go there? So one connects, the other protects.
So our little data packet is now hopping from router to router, getting closer and closer to its destination. But let's be real, the internet isn't always a friendly neighborhood. There are dangers lurking out there, and the server it's trying to reach could very well be under attack.
So let's look at one really common threat, something called a TCP SYN flood.
This is a classic brute force attack. It's not trying to steal data, it's trying to shut a server down completely by just overwhelming it, flooding it with connection requests until it gets knocked offline and nobody can get through.
Here's how it works. The attacker just bombards the server with thousands of connection requests. These are called SYN packets. The server, trying to be helpful, replies to every single one and sets aside a little bit of memory waiting for the final handshake to complete the connection. But the attacker never sends that final reply. So these half-open connections just start piling up and up and up until the server completely runs out of memory and can't accept any new legitimate requests. It's basically death by 1,000 paper cuts.
And this really brings the whole layered model we talked about back into sharp focus. A SYN flood is an attack on the transport layer, but a good defense has to happen across multiple layers. You need filtering at the network level, you need monitoring at the transport level, and you need resilience built right into the application itself. It's a powerful reminder that real security isn't just one magic box. It's a whole system of defenses all working together.
But let's be optimistic. Let's say our packet's destination server is healthy, it's well defended. Our packet has successfully navigated the entire global network, it's dodged all the attacks, and it's arrived safely. But guess what? The journey is only half over.
The server gets your request, finds the web page or the image or whatever data you asked for, and packages it up for the return trip. This brand new packet, the one containing the data you actually wanted, now has your IP address as its destination, and it begins the exact same incredible journey, hopping across routers all the way back to your screen. So, what did we learn on this little trip? Well, first, that your single click isn't one thing at all. It's actually a whole stream of tiny packets, like letters being sent back and forth. Second, this entire system only works because of a shared rulebook, and honestly, a surprising amount of trust between all these computers. Third, we learned that common buzzwords like internal or encrypted don't automatically mean safe. And finally, that real security comes from layers of defense, a whole series of checkpoints, all working together.
So the next time you click something, just take a second and picture that incredible invisible journey. Your data is being shot out into a global network of millions of devices, all cooperating to bring you an answer in less than a second. It's a system of just mind-boggling complexity that we all take completely for granted. So the final question is, now that you know the path, are you thinking a little differently about the journey?